In this video, we look at the sum to infinity of a geometric series. Now, the only time we can get the sum to infinity is if the absolute value of, or the common ratio, is less than 1. Because if the common ratio is greater than 1, then we would have something like maybe the common ratio would be 3, and you could have something like 2 plus 6 plus 18 plus 54 and so on. And of course the limit of that doesn't exist because it just continues on. So where the common ratio, the absolute value of the common ratio is less than 1, we've this formula. The limit of Sn as n tends to infinity is a over 1 minus r. Let's look at part 3 of this question. We want to find the sum to infinity of it. So the series is 7 minus 7 over 3 plus 7 over 9 and so on. Once again, a is equal to 7 and or the common ratio is minus 1/3 because we multiply 7 by minus 1/3 to get minus 7 over 3. Let's check if s to infinity exists. The absolute value of r is less than 1 because the absolute value of r here is 1/3, and therefore the sum to infinity is a over 1 minus r. We just plug that in then. S to infinity is a, which is 7, over 1 minus 1/3. That gives us 7 over 1 plus 1/3, or 7 over 4 over 3, which is 21 over 4. Now, before you move on, pause the video and do part 5 of this. In this question, we're asked to find the range of values of x for which the series converges. But we remember that a series will converge if the absolute value of the common ratio is less than 1. So in the series, in part 2, 1 plus 2x plus 4x squared and so on, a is 1, the common ratio of 2x is 2x, so Sn will converge if and only if the absolute value of, or the common ratio, is less than 1. It's like getting a sum to infinity. That's what converges means, that you can get the sum to infinity. So, in other words, the absolute value of 2x must be less than 1. That means that 2x must be between minus 1 and plus 1, and therefore x must lie between minus a half and plus a half. Once again, you'll want to pause the video now and maybe try part 3 of this question.